Hello and welcome to High Voltage Engineering. We are continuing with the topic generation of high voltage and currents. In this class, we'll be talking about generation of impulse voltages. In the previous class, we have seen the basic of the definition of an impulse and the circuits that produce impulse voltages. Now we'll be talking about a special circuit called the Mach circuit. So it is a multi-stage impulse generator which is called the Mach circuit. The circuit is given on the right hand side bottom. Okay. So what is the importance of the Mach circuit is that the constant size of the impulse generator increases at the rate of square or cube of the voltage rating. So if you want a more voltage, the equipments that are required will be more expensive. So the Mach circuit is nothing but the arrangement of the capacitor and resistance in cascade fashion, which gives you the higher voltage but at a lesser price. Okay, so for producing a very high voltage, a bank capacitor are charged in parallel and then discharged in series. Okay, the arrangement of the charging of the capacitors in parallel and then connecting them in series for discharging was originally proposed by Marx. So what it happens is that there are number of capacitors that are charged and in parallel, so they are charged at the same voltage, but during the discharge they are turned into series so that you can have more amount of the voltage gets add up. The voltage adds up. Okay. So usually the charging resistance Rs is chosen to limit the charging current to about 50 to 100 milliamperes, and the generator capacitor C is chosen such that the product of the CRS is about 10 seconds to 1 minute. So CRS is nothing but the time constant of the circuit. The gap spacing is chosen such that the breakdown voltage of the gap G, look for the gap G, is greater than the charging voltage. Thus all the capacitors are charged to a voltage V in about 1 minute. Okay, you can see without this gap charging, all these capacitors are in parallel. Okay, so they are charged with a particular voltage. Thus all the capacitors generated now the gaps are made to spark over simultaneously with some external means. Now when you allow the gaps to spark, so these capacitors are now turned into series. Okay, and so the discharge time constant CR1 by N for the N number of stages will be very small, that is in microsecond, compared to the charging time of the charging time constant, that is CRS, which will be a few seconds. So what happens is that during the charging, the time constant CRS will be around certain amount of seconds, but when it is discharged, since it is the capacitors are turned in series, and the CR1 by N becomes the time constant of the capacitor. The time constant, the time required is very small, around in terms of microseconds. So in a microsecond you will get huge amount of voltage. So hence no discharge takes place to the charging resistor Rs. So since the time is very small, the discharge is not affected, do not affect the resistance Rs. Now we have this was the previous Mach circuit. Now we have a modified Mach circuit. Okay, so the modified Mach circuit is given on the right hand side. So what is the difference? The resistance R1 and R2 are incorporated inside the unit. R1 is divided into n parts. Okay, so what is the difference? The resistance is divided into n number of parts equal to R1 by n, and they put in series with the gap G. R2 is also divided into n parts and arranged across each capacitor unit after the gap G. So you can get R1 and R2 in the previous, okay, so compared to the previous circuit, you can see the R1 and R2, these are two resistances. They are divided into n number of parts, and they are arranged in the diagram shown. This arrangement saves space and also cost is reduced. But in case of wave shape to be varied widely, the variation becomes difficult. The additional advantage gained by distributing R1 and R2 inside the unit are the control resistor are smaller in size and efficiency is high. So what is the difference? So two advantages we have found out. One is the higher efficiency since the resistance are divided into equal parts, and second it takes a less amount of space, and even there is a low amount of cost. The impulse generators are nominally rated by the total voltage, that is nominal, the number of stages and the gross energy stored. So this is how the impulse generator are named. The nominal output voltage in the number of stages multiplied by the charging voltage. The nominal energy stored is given by C1 into V2, where C1 is nothing but C divided by N. That is the discharge capacitance divided by the number of stages. And V is the nominal maximum voltage, that is N times the charging voltage. Okay, so the number of stages being N, the capacitance C1 is defined as C by N, and the voltage, the maximum voltage obtained is N into the applied voltage. Okay. Now we'll talk about the components of multi-stage impulse generator. What are the different components that we find in an impulse generator? One is a DC charging set. Okay, so this DC charging unit should be capable of giving a variable DC voltage of either polarity to charge a generator capacitor in the required value. So this DC charging set should be capable of providing a various DC voltage to the impulse generator. Then it should have a charging resistor. Now what is the function of the charging resistor? This will be non-inductive high value resistor to about 10 to 100 kilo ohm. Each resistor will be designed to have a maximum voltage between 50 to 100 kV. The third part is the generator capacitors and spark gaps. So these are important part of the multi-stage impulse generator. So these are arranged vertically over one over the other with all the spark gaps aligned. The capacitors are designed for several charging and discharging operation. On a dead short circuit, the capacitors will be capable of giving a 10 kiloampere of current. The spark gaps will be usually spheres or hemispheres of 10 to 25 centimeter diameter. Sometimes spherical ended cylinders with central support may also use. So this is a basic description of how the spark gaps and capacitors are there in the multi-stage impulse generator. Then the other components are the wave shaping resistor and capacitor. So what does this resistor capacitor do? It changes the shape of the impulse. So these resistors will be non-inductive wound type and should be capable of discharging impulse current of 1000 amperes or more. Each resistor will be designed for a maximum voltage of 50 to 100 kV. The resistances are bifilar bound, that is bound in both sides on non-inductive thin flat insulating sheets. Modern impulse generators have their wave shaping resistors included internally with a flexibility to add additional resistor outside. when the generator capacitor is charged. Okay, so this is a basic description of the wave shaping resistors. Now the next component is the triggering system. This consists of trigger sparks gap to cause spark breakdown of the gaps. So you need these breakdown in order to change the capacitor from parallel to series, and these are the triggering system. Then we have a voltage dividers. The voltage divider are either damped capacitors or resistor type, and an oscilloscope with recording arrangement are provided to measure the voltage across the test objects. So why these voltages are required? These voltages are required for the measurement, okay, of the what is the amount of voltage that is being created. Now you cannot measure the voltage to be of that high voltage, so we need to divide the voltage and measure only a part of it, so that we can have an idea of the maximum voltage. Okay. And the last component is the gas insulated impulse generators. Impulse generators are rated for 10 megavolt and above will be very tall and require large space. As such, they are usually located in open space and housed in an insulated enclosure. The height of 4.8 megavolt unit may be around 30 meters. To make a unit compact, a compressed gas such as nitrogen or SF6 used as an insulation. So if you need a bigger insulators, the insulator size will be very high. So you can have an idea of a 4.8 megavolt impulse generator, you need a height of 30 meters. So you need it to, for the compact impulse generator, the height can be reduced with an insulation of nitrogen or sulfur hexafluoride. Next topic is generation of switching surges. Now what are these switching surges? A switching surge is a short duration of transient voltage produced in the system due to sudden opening or closing of a switch or circuit breaker, or due to an arcing at a fault in the system. Waveform is not unique. The transient voltage may be an oscillatory wave or a damped oscillation wave of frequency ranging from a few hundred hertz to a few kilohertz. So one is the impulse and another is the surge. Surge is again that kind of impulse, but in the surge the rise time is a bit longer. Okay, so on the right hand side you can see a typical surge creating circuit being provided. So it is also of the two types, one which have a straight, so you can see the output being straight going up and going down, and the others, the one while the output coming down it oscillates. So you can, from this two kind of circuit you can get two kinds of output. So it may be considered as a slow rise impulse. As I've told you, the rise time is bigger. So the switching surge is nothing but a slow rising impulse having a wavefront time of 0.1 to 10 microsecond and tail time is about several microsecond. Such switching surges contain large energy than an lightning impulse voltage. Several circuits have been adapted for producing the switching surges. So of these two circuits, two are important here. One is the impulse generator circuit modified to give a large duration wave shape shown in circuit A, and power transformer for testing transformer excited by DC voltages giving an oscillatory wave, and these include Tesla coil. So these are given by the impulse circuits on the other circuit, that is the circuit number B. Okay, so these are the two circuits that produces the switching surges. Okay, so this is the end of the class. Thank you.